Hold on to your hats, boys and girls, because we are going to do some algebra. All right, we're looking at this. We're supposed to, by the way, should give you the fun words that go with this. It should say, if you, at least most calc books say, I'm not actually sure your college algebra book says, but I love this. You are supposed to decompose into partial fractions. You gotta love it. How often do you get to decompose something? So, yes, we're taking this fraction apart. Now, what evil and nasty thing have I done? I gave you a fraction in which the denominator is not factored. Oh no! So, after 8 lessons today, sorry, I'm getting a little punchy. We need to factor that, and I intentionally did mean and evil. Sorry, but I did. So we need to factor this puppy. How do you factor a 4-term expression? And I know, being the on the ball with the people that you are, you're out there screaming, groupie! So let's group. And what can I pull out of my group? My first group, of course, I can pull out x squared, and I'll be left with x plus 3. My second group, I can pull out a 4, and I'll be left with x plus 3. Now, the big question, am I done with grouping? Obviously, after that, boys, no, I'm not. Remember, grouping takes 2 steps. You now have a group here and a group here. What is the common factor you can pull out of both groups? Well, I can pull x plus 3 to the front of both of those, which will leave me with x squared plus 4. Okay, you don't have factors until you have multiplied quantities. That plus sign up there in the step above, you can't have that. So now I can see, and I'm going to rewrite because people tend to get messed up if I don't. So I'm rewriting the original problem here, and it now has this lovely common denominator in factored form. So your task is then set up what the book calls the templates. But in other words, what are the separate fractions that could have happened in this problem? Well, neither of those factors farther, so I'm going to have an x plus 3 in one. I'm going to have an x squared plus 4 in the other. All right, here we go with the a's, b's, c's, d's, however many it takes. What's going up top? Well, this first one, I have x to the first power, so one less than that would be a constant. The second one has x to the second power, so one less would be a first power. But since I have to go down to a constant, I would also need to add a plus c. Okay, there is my setup. Now, what's my next step? Get rid of the fractions. So, how do I get rid of the fractions? Well, by doing what all good mathematicians do, they multiply by the common denominator and ditch the fractions. Okay, what is the common denominator you always use without fail, without even thinking about it? It's the original factors you started the problem with. We started this problem with x plus 3 and x squared plus 4, and so that's what you're going to multiply by, nothing else. Okay, obviously every single time it's going to cancel the first ones. And so you'll always just be left with the original numerator. Never any doubt on that one. Okay, it's over here on the individual fractions where you need to be careful. So I am now multiplying the first fraction here with my x plus 3 and x squared plus 4. And once again, write one extra line and save yourself a lot of heartache. What's going to cancel? X plus 3. What's going to be left? A and x squared plus 4. Once again, yeah, you could distribute that and it wouldn't be that difficult. Okay, but next one, not so much. This is where I see errors. I'm going to take this one times x plus 3 and x squared plus 4. What's going to cancel? X squared plus 4. What's going to be left? Not so nice. That whole bx plus c on top and the x plus 3. Now, yeah, some of you can foil that. Some of you write neatly and organized enough to do it. Don't. Do it my way. Save yourself a lot of heartache. and a lot of frustration. So now, it's algebra. I am going to distribute the a, which will give me ax squared plus 4a. The other ones here, yes, indeed, I get to FOIL. So firsts, outers, inners, and last. Be very careful that you keep track of the x's and the power on the x's, because now is the other key step. Step we always forget. How do I get to a system of equations that I can solve? So we're going to use the coefficients of like terms. I need to write that in a different color, though, so that doesn't... Let's be of like power So here we go. What's the highest power I see here? I see 10x squared. Let's see, x squared. Now, once in a while, I will point this out here. It's a good place to talk about it. What would happen if over here, if this had been ax cubed, but on the left side, you don't have any x cubed? Well, it's like you have 0x cubed. So if there's a missing term somewhere here on the left side, treat it like it's a 0. Okay, I'm, however, now getting rid of that stuff. All right, so now we're doing like power. So I'm going, all right, I have a 10x squared. What other x squared terms do I see? Go find them. 10, I see an a, I see a b. So I know then that I'm going to have the equation 10 equals a plus b. Then I'm going to go do the same thing looking for x terms. I got a 24, a 3b, and a 1c. So I know I'm going to have the equation 24 equals 3b plus c. But, okay, notice that one's missing an a. The first one was missing a c. To save yourself a lot of heartache, you will find it easier if you start lining these babies up as you write them. So I'm going to make sure I get my b's and c's lined up under each other correctly. It'll make doing my matrix equation easier in a moment. Then lastly, I'm going to go look for my constant numbers. And I have an 8, a 4a, and a plus 3c. So 8 equals, and once again, paying attention to how I line them up, 4a plus 3c. If you want to, you can go ahead and fill the zeros in if you like, because that means we have a plus 0c here. It means we have a 0a here and a 0b here. So if that helps, if you like the zeros in there, put them in there. Once again, you could solve this problem by doing 2 substitutions, or a substitution then an elimination. But since we're in the matrix chapter, they really want you to solve it with matrices. You could do an augmented matrix here if it really floats your boat. I'm going to opt for a quick and fast matrix equation. So if I go shove this thing in a matrix equation, it's actually in reverse order here. I'm going to do the ABCs first. Going down the A's, I've got a 1, 0, 4. The B's, I've got a 1, 3, 0. And the C's, I have a 0, 1, 3. I'm going to use an inverse and times it by the result matrix, which is 10, 24, and 8. If you do that, punch that in your handy-dandy calculator, you are going to get answers of 280. Now, what does that mean? Well, that's A, B, and C right there. We now know A is 2, B is 8, C is 0. You need to go back to your original setup where you set up the A's and B's originally. And it was originally supposed to be A over x plus 3. And this thing won't stop. So I need to come back down here and go, okay, I should have then as a final answer a, which is 2, and it's not keeping up with me. So I would have 2, and it's still not keeping up with me. I'd have 2 over x plus 3 plus, what was my other fraction? I'd be x plus c over x squared plus 4. So x squared plus 4, I was supposed to have bx plus c, so I would have 8x. C is 0, so there wasn't a plus c. It was just 8x over x squared plus 4. And there you have found the original fractions. Now, I guess I forgot to address the question, why would anybody do this and why do we care? Well, I can't lie to you on this one, other than it's cool algebra. But in reality, this is totally and completely so that you have this skill to use in Calc 2. So if you're planning to take Calc 2, you're going to be great when you get to partial fractions, but it is purely that. In Calc 2, we have to take this nasty fraction, break it down, and then we have to do what's called integrating each of those individual pieces. So in calculus, this is only halfway through the problem. Then you have to do the calculus on this stuff you've created. Ask my calc class here in a couple weeks because we're about to get there. We do it in April. Or actually, I take that back. You won't be watching this video till April. They'll probably already have done it by the time you get to this. Or they could possibly even be on it right at the same time. Alrighty. I want to do one more just because some people need the extra. If you don't, if you think you've got it, go for it. This one has a unique setup at least. You may want to stick around to just watch me set it up, if nothing else. Because once again, I've been mean and I didn't factor it for you. First thing I would notice about this denominator is that I can pull an x out. And then that would be a quadratic that I'm pretty sure I can unfoil. And that would indeed be x plus 2 and x plus 2. How should I write that? That's kind of interesting. So I am going to rewrite this thing, leaving the numerator as is. But the denominator, I have x plus 2 twice. So that would make me have an x plus 2 quantity squared. Okay, warning bells are ringing in your ears, lights are flashing, you're going, oh, this is one I have to be careful how I set up. And yeah, this is the one you have to be super careful of. Yes, there's going to be a fraction with an x. That's the easy one. Yes, there's going to be a fraction with x plus 2 squared, because we know the common denominator had 2 of them in it. But we also know there could have been another fraction that had 1 x plus 2 in it, because that still would have been part of the common denominator. So we have to deal with all of them, even though we're not sure if they're there or not. Like I said, the a, b's, and c's, if it doesn't work out, it'll turn out to be 0 if it's not supposed to be there. Okay, so checking what to put on top. X to the first power, 1 less is a constant. This one you use the power on the x inside, so it's first power, another just constant. And the third one, of course, is also x to the first power. So we're only looking at a, b, and c. It's not that bad. All right, the other place that we messed this one up is right here. We've got to solve it, and I have people put their brains in gear when I don't want them to. I am going to times this by the common denominator. To get rid of my fractions. But what is that common denominator I'm going to multiply by? Is it going to be x plus 2 squared, and x plus 2 to the first? The answer is no. It's always the original denominator, this one. This baby right here. Always the original common denominator is what you multiply by without fail. So I'm multiplying by x and x plus 2 squared, which is, of course, going, as always, to cancel the original fraction. always. So I will be left with 4x squared plus 21x plus 16. Now, go through the rest of it and ask yourself what cancels what's left, and this is the one that you can get really messed up on. If you don't write down what's left, don't try to multiply this right now. Okay, if I take that fraction times the common denominator, I'm going to cancel an x, and I'm going to be left with an a and x plus 2 squared. We'll deal with that in a minute. Next one, I'm going to take that times x and x plus 2 squared. And this time, okay, that's good news. The whole x plus 2 squared's gone. We like that. We are left with bx. That's a good thing. And then this is the one. When I take that times x and x plus 2 squared, I'm asking myself, what cancels? The x plus 2, one of them cancels. There is still one of them left. So you have a c, an x, and a single x plus 2 left. Can't emphasize enough the need to write that down, pay attention to what's going to be left. Don't worry about multiplying it all together. Okay, I'm now going to do the algebra. And I'm actually going to shortcut this one just slightly here. We know that when you FOIL that, that's x squared plus 4x plus 4. I'm going to trust you can FOIL. So therefore, that means I can distribute a, and I'll have ax squared plus 4ax plus 4a. Bx is going to sit there, and then I just need to distribute cx, which will be cx squared plus 2cx. Once again, second stalling place for people. They get here, and then it's like, well, what do I do? You need your system of equations. How do you get your system of equations? You start pulling out the coefficients of like powers. So once again, I go looking for squares. 4x squared, ax squared, cx squared. So that means I have the equation 4 equals a plus c. I go get the x's. I got a 21x, a 4ax, a bx, and a 2cx. Ooh. What mistake did I make when I wrote down the first one? I didn't space it out. Because now I'm going to have 4a plus b plus 2c. So up here on the first line, I should have stuck that plus c out there so they'll stack up right. And then finally, 16 equals, getting my constant numbers that I can spot out here, 16, 4a. That's it. Oh, cool. Okay, now you have a choice. You could run this in a matrix equation. But seriously, why? Because what just happened with that third equation? Yeah, it's solvable. We just found out, I'm coming up over here, if 4a equals 16, then we just found out that a equals 4. And if I know a equals 4, I can now go to the top equation. I know 4 equals a plus c. So now I can put my 4 in for a, and c is going to solve out to be, 0. And then, finally, I know a and c, so I can use that third equation and go solve for b. So a is 4, that's going to give me 16. I'm solving for b, and c is 0. So that means b is going to equal 5. And once again, writing my final answer, I'll now have a fraction of 4 over x plus b was 5 over x plus 2 quantity squared. But because c was 0, it means that last fraction was actually indeed missing. I don't need it, so I just have this final result. How cool is that? I find this fascinating. Of course, I love to do lots of intense algebra, so this is really great fun. But the fact that I can take a fraction and pull it apart back into pieces, this is cool. Dig this. All right. Be sure you check about changes in the assignment. It's actually on the last assignment, there were some changes in. Actually, I think there's some changes on this one too, so be sure you check those changes. Make sure you've got it. Enjoy the algebra.